This is a conical pendulum type of arrangement in which a slender bar, means very thin bar of length L and mass m, and it rotates with a constant angular velocity like this. We have to find out the value of alpha. See, as it is moving, the center of mass will be moving in a circular path of how much the radius, it will be L by 2 sine alpha. Therefore, the centrifugal force, it will be experiencing m omega square L by 2 sine alpha apart from mg. Now we can say in the rotating rod frame of reference, net torque about the hinge is 0, because this rod is maintaining a constant angle alpha with the vertical. So therefore the net torque will be 0. So m omega square L by 2 sine alpha, this multiplied by the perpendicular distance, which is L by 2 cos alpha, this is this direction torque, and this direction torque will be equal to mg multiplied by the perpendicular distance L by 2 sine alpha. You are able to understand that L by 2 sine alpha get cancelled. We have omega square L by 2 cos alpha is equal to mg, and from there m, I think it will again let it be cancelled, and we have cos alpha is equal to 2g divided by omega square L, or alpha is equal to cos inverse 2g divided by omega square L. This is the angle made by the rotating rod with the vertical.